Quick. All right, thank you very much. So I appreciate everybody showing up at the end of the day. Thanks a lot. My name is Joel Yoker. I am an architect within our America's CTO office. So I focus mostly on cloud-related technologies and have been working in this space for quite a while. I also lead the Azure Infrastructure as a Service COE. And part of the things that I've been doing and responsible for is I work with a team called Solution Factory. It works directly with the product team. And we build a lot of reference architecture material you may be familiar with if you've pulled them down online from, or if you've worked with an OEM, or maybe you've had a partner or MCS come in and actually do some work with you. They've likely used some of the materials that we've put out to be able to fill some of that design gap. So what I'm going to talk to you today about is an area that I've spent a lot of time on over the years, and the product group asked me to come out and talk about our product line architectures for infrastructure as a service. Primarily that private cloud space and how to deploy System Center and how to deploy Hyper-V to build a private cloud. And you may be wondering yourself, for someone that focuses on Azure, why is this important? Why are they out here talking to us about it? It's because we have a strategy, and you've seen this kind of presented over and over again around Cloud OS and what Cloud OS means to us. And it's a three-legged stool, right? If you have two legs on a stool, you're really doing a balancing act. So what we're really trying to do is provide a holistic message, because we've seen from customers, and we hear from customers over and over, that hybrid cloud is probably where they're going to be for a very long time as they make this journey into the public cloud space. And it's based on a lot of different things, right? So you have your private cloud infrastructure, which gives you a lot of flexibility and control. There's reasons. Maybe those reasons are data-driven. Maybe they're security-driven, compliance-driven, might be cost-driven. That you need to keep these things internal to your organization. And that's where private cloud really fits and provides a means for you to be able to host those workloads. Other workloads you might want to host in our public cloud offerings and take advantage of some of the innovations and capabilities that we have inside Azure, or you're looking to our Cloud OS network and those service providers that are providing kind of some cutting-edge capabilities at a lower cost and dropping your OpEx, but still allowing you to have that security and control that you need in your environment. So regardless of those business reasons, you want to have a single platform, and you want to make it easy to be able to move or decide where that workload goes based on those decision points that I discussed earlier. You don't want to just do it based on what you have. So we think that private cloud's still a very important space for us to be able to kind of cover, and that's why we've built these resilient kind of reference architectures to help you build those internally, either by yourself, with a partner, or possibly with services or an OEM. And just as a raise of hands, how many people are familiar with the Infrastructure as a Service PLA? Have pulled it down, looked at it? Okay. So for those who've actually seen it and gone through it, or maybe deployed it, I'm going to walk through a lot of different areas. I'm going to give you some background as to how we arrived at this, and then I'm going to spend some time going through the different areas inside of it and give you some of those decision points. If you ever scratched your head and wondered why we did that or why we made a decision, I'll try to cover those areas. The other areas we'll do, for those who aren't familiar, hopefully this is a good kind of overview that'll get you kind of indoctrinated as to what we see as private cloud. Along that journey, kind of looking at Cloud OS, right, there's a lot of different challenges that customers have, and we see it too. The first one is the business. This is the organization that's paying for your cloud, right? And they ultimately have a lot of expectations. They have a lot of desires and goals to be able to further their business, but they have a very business-minded view of it. The problem is that a lot of organizations still struggle with getting cost of ownership understood, so making sure they understand how much their cloud infrastructure costs, being able to translate that back into show-back and charge-back models. A lot of the business constructs that live outside of technology, that people and process area, really needs to be identified up front for you to be able to deliver those cloud attributes. The second is there's a lot of technology. We're throwing tons of technology at, to build these cloud architectures on premises. So you have to be a storage expert, a network expert. You need to understand all of the integration points. You need to understand service delivery. You have to understand all of these System Center components that we toss at you to provide all of this rich capability. You have to be an operations specialist. And you have to tie all that together and provide a cohesive platform to meet the business's needs. Expectations is probably one of the biggest ones that I see. We're all consumers. We live in this consumer world. We're used to consuming services either in our private lives or even in the business. So as you go out and try to do this, you've built this expectation, and your organization has as well, built this kind of expectation that things should be very simple, that they should have this perception of unlimited capacity, that things should happen very quickly. And when they're not met, that goes at odds against what the IT group is able to deliver. Because the IT group suddenly in private cloud becomes the provider. So all this burden of providing all these wonderful capabilities falls on you. And ultimately, there's a little bit of misalignment there. Along with all that technology, you have to have a skill set that goes with it. And how many people are familiar with one or more system center components that would consider yourself an expert? So not many hands go up in the air when we say, all of those. So it takes a team of people. So you need to understand what different roles people have and what different capabilities are out there. And we'll talk about the different components that we use and how to stitch those together. We don't want to go backwards. And then last but not least is integration. You need to tie all of these things together that I described earlier so that you can have a kind of a cohesive front. So you can call it a cloud. So you can deliver on those attributes that are defined by NIST Special Publication 800-145. You want to be able to have elasticity. You want to be able to have capacity on demand. You want to have full transparency. And that requires a level of integration that's very hard to achieve in some cases. Ultimately, we want to be able to build that platform. So we have a very simplistic approach around this. We've kind of took a step back and said, what does it take? Well, it takes some hardware, it takes a really rich software suite, and we need to be able to provide some solutions. So with our hardware, we really are looking to our OEMs. I'm going to talk about this program called Fast Track. You may be familiar, and hopefully you've seen some sessions on our cloud platform system. That's a partnership with an OEM out there. But really what we want to be able to do is make it very simple to transact on that. Second is we have to have a kind of a world-class software suite to be able to deliver on all of those cloud attributes, to give you kind of a rich capability from the cloud. And that's in the form of Windows Server, specifically Hyper-V, System Center, and then our Azure, Microsoft Azure, and Azure Pack. And then what we're here to talk about today is really we need to have some prescriptive architectures. We need to make it very simple for you to be able to build this, and we need to give you a lot of information so that you can do this successfully and not in a piecemeal way. So the PLA is really a solution, and I'm going to talk about the pieces and how we got there. Now, one of the challenges we have is there's just no shortage of guidance out there. If you go out and you search private cloud Microsoft, private cloud System Center, just private cloud in general, you're going to get a lot of information thrown at you. And that information ends up through different blogs, gets copied and reproduced, and a lot of different information exists out there. And what we call that is islands of best practice. So there's no shortage of people trying to tell you the best way to do something. And what we want to do is give you a way to do things so that you can arrive at the outcomes that you need, but doing it very quickly. The next is that you need, I think organizations tend to go through what we call deployment exhaustion, right? You purchase all the stuff, you spent so much energy trying to get to all the hardware and software that's needed, but then you spend a lot of time starting and finishing different areas of your project, but you're never actually able to really realize that capability. So we need to increase that time of market. We need to reduce that deployment exhaustion so we don't have these long planning cycles. We want you to get it right the first time. We want to take out some of the complexity. So by giving you some of the things that we know as we actually define this architecture through deployment testing and through product group interaction, making sure that you know all the gotchas up front, so that you can kind of navigate through them versus finding them. And then last but not least is trying to provide a level of compatibility so that when, with our other properties that we talked about, the CloudOS network partners, our solution providers, and then also Microsoft Azure, we want to make sure that you can be able to move those workloads based on your needs and based on those decision points I talked about, not based on compatibility changes because you built something fundamentally different. So, there's no shortage of projects out there, and people look to run these as workloads. And so what we have to do is we have to build a base for that. And the base is really Windows Server and System Center. And what we call that is the Infrastructure as a Service PLA. And the way we define that is we build a reference architecture based on a service description. And our service description is really simple. We say that we need to be able to provide a private cloud infrastructure that consists of 4 to 64 hosts that can support up to 8,000 VMs. And that's our model that we start with. So that's the base assumption that we have going into this entire architecture that we build. Now, you can build things that are quite larger than that, but if you're following the PLA, this gives you that first fundamental starting point. So Once we do that, we build a set of rules. We say, what are the types of things that we want organizations, customers, partners, OEMs, across this entire ecosystem, what are the things that we want to make sure that they have? We need to make sure that certain things are mandatory. So when you see a great example at one of these sessions of how we can do live migration with RDMA, you know that you can buy, with confidence, one of our fast track SKUs that supports that, right? If you see some great blog post that talks about some tools that you can use to automate scenarios and you say, gosh, I want to be able to use that, you have the components of System Center there so that they can actually be realized, that you're not one component short or one capability short or one piece of integration short of realizing that benefit very quickly. And so we pull those together in rule sets, and we say some of these are mandatory, some of these are recommended, and some of these are generally optional or just general good ideas. So we pull that together along with the deployment model because we have a lot of these deployments we're helping customers with, and we want to be able to provide one source of guidance that we can share across this entire ecosystem I showed you earlier. So in the world of architecture, you have reference models, which give birth to reference architectures, which give birth to reference implementations, right? So if you think about CPS, the Cloud Platform System, that's a reference implementation along with FlexPod and a lot of these other solutions that are coming out from our OEMs. They're based on a reference architecture that we go ahead and send out. That's what the PLA does. But it all starts with this, and this is the Cloud Services Foundation Reference Model, or CSFRM for short. And CSFRM was built by a large team of people, including a gentleman named Jim Dial and Tom Schindler, which you probably have gone out and pulled some of the information that he has on our Building Clouds blog. But what this is it's kind of a vendor-agnostic view. It's as if you have to build a cloud service, what does it consist of? And they, after a lot of gnashing of teeth in meetings and discussions and whiteboard sessions, came up with CSFRM and said, essentially, there's these subdomains of capability. We need to have an infrastructure, and that infrastructure has to have software and platform as part of it, and that's one subdomain. We need to have a management structure that provides management and support interfaces, and those are defined interfaces that support that platform that gets deployed. There needs to be a level of operations that embodies all of this. And then if you need to be able to deliver any type of service in the form of a workload, you need to have a service delivery model to be able to accept those requests and send that out. It's pretty simplistic, but it's actually really good words of wisdom. And if you follow the PLA and you download the documents, you'll see that the areas covered in blue are really what we're focused on. That's our level that we're doing inside the PLA. We have other content that covers some of those other areas. But this becomes a bit of a guiding star that you can apply to pretty much any vendor solution that's out there. So diving into the PLA, what is in the PLA? Well, the PLA is actually a collection of documentation that we provide. And it's 3 primary documents. And we have a lot of other materials that come to be able to support it. But if I had to think of the core, this is the 3 core areas. First, there is a fabric architecture guide, how to build Windows Server Windows Server Hyper-V in the form of one or more fabric clusters to be able to host virtual machines. And a lot of very clear guidance on how you can get there. Fabric management architecture is primarily focused around System Center and Windows Azure Pack. What are the deployment design patterns that we want to be able to use to enable a certain set of outcomes? And then last but not least is the deployment guide. And to wrap this up, we've tried to provide a click-by-click, step-by-step documentation on how you can actually deploy all of these components in what we would consider to be a full suite deployment based on that infrastructure as a service description I described earlier, what we're trying to achieve. So these are the 3 areas, and I'm going to dive into the high-level parts of each one of these so you get a clear idea of what those components are. So if we look at Fabric, one of the key concepts, one of the nuggets out of the document is we make a clear distinction. We've been doing this for years, and we actually get a lot of pushback initially, and now it seems like a lot of the thinking is caught up with this. But we separate what we consider to be Fabric and Fabric management. Now, when we separate these, we separate them based on a Hyper-V cluster, because all of our workloads, either for management or workloads that we're running, will all be virtualized in our environment. So we need to be able to separate those into 2 separate clusters for a bunch of reasons. Primarily, we expect that you're going to have more than one fabric cluster in here. You can start with one, and that's a great place to start, but if you're building a cloud infrastructure, you need to be able to expand based on the capacity needs of the organization. Again, you're the provider. You need to be able to see when that capacity is at a certain level. Once it does, you need to go ahead and make orders and expand your fabric. You may have different needs. You may have a VDI infrastructure that has different specialized hardware, and you need to be able to segment that. Or you have a different class of hardware, and you're starting to evolve your infrastructure, and you need to build another cluster for that. We need to separate that from the fabric management tools. We don't want to deploy System Center and Azure Pack on the fabric itself, because we need to be able to abstract it from the fabric model that's out there. So we tend to separate those, and that's what these two models are. We say System Center and Azure Pack needs to live in a separate Hyper-V cluster that can run independent. It's not going to affect placement guidance and predictability and all of the different capacity reports that we get out of VMM. It's not going to go ahead and affect any of our maintenance operations, and it allows us to spread these out evenly and provide some predictable patterns as to where we actually will host different workloads. For the fabric, again, for a lot of reasons, we expect that you will have more than one Hyper-V cluster, and we want to treat that much in a separate manner, primarily for expandability. So we talked about hardware being an important point, and this is where I want to talk a little bit about our Fast Track program. So Fast Track is a model that we've used to be able to go ahead and provide validated designs from a large number of hardware vendors, because what we want to be able to do in this model is provide you a lot of choice. We know that organizations have certain affinity to certain brands, and we've tossed up a few of these brands here, and I'll throw the rest of them out here. But the idea is that you need to be able to choose very simply. The back of the napkin game happens very quick when it comes to hardware. You need to understand how many cables are connected. Do you have enough port density? What's the phase of power that's required? Do we even have a separate management server cluster that's been built? And are we shipping enough hardware to support this? For all those reasons, we created this program so we could work with our OEMs to come up with a validated design. Now, their architecture happens to be the PLA. So previously, the same people that worked on what is now the PLA worked on Fast Track architecture as well. And we had this thing called dueling architectures, we said, where you had one group that was publishing something through our OEMs and another group that was publishing it externally, and we were trying to rationalize those largely based on the same constructs, but they weren't the same. And no longer is that the case. We've actually normalized that for the last 3 revisions so that you can go out and very simply work with any one of these, and you can go out to the website, any one of these vendors, and select based on your needs and the capabilities and the design patterns I'm going to talk about here in a minute, what you can use to build a private cloud. So ultimately, we want to make sure that we shorten this cycle, again, trying to get out of that design and planning cycle and giving you something you can pick up off the shelf, and moving to more of a SKU model with a wide range of customers or a wide range of OEMs. So once you've purchased your hardware, you've grabbed all of that content and you've made that, you need to be able to decide, or maybe you're deciding this ahead of time, what is it that you're going to deploy. And what we build inside basically every one of our different guides is these things called design patterns. And patterns are really simple. It's just a way for us to provide some choice with guardrails. We know that there are certain affinities to specific technologies. We know that there are investments that you may have made in your organization. We know that there are some aspirational goals and some drivers. But what we did was we built a series of patterns so that you could get to the end result. Again, back to that service description, 4 to 64 hosts, 8,000 virtual machines. So when you look at this, I mean, everybody remembers maybe when they were a child reading those books that were, choose your own adventure. If Billy went through one door, well, he might fall in a well, right? And if Billy went through the other door, well, it's a birthday party for him. And we would end up reading the book, and we'd get to the end, and you'd have to reread it over and over again. And just to get to that best outcome that you wanted. And maybe you were lucky enough the first time to get to that great outcome. Well, what we wanted to do is build something that was choose your own adventure that would help you get to the same model. Again, get to that service description. Because the IT organizations out there do not have the time and money to waste with all of these different, trying to analyze the market and come up with a bad result. So we know that there are certain drivers and certain capabilities, so we built these into patterns based on what the market is shipping and based on the work we've done with our OEMs. And those 3 patterns, which I'll go through here in a minute, are non-converged, converged, and software-defined infrastructure. So the non-converged pattern is a legacy pattern that we've had. This is one that we've had for a very long time. This is the way most organizations deployed cloud several years ago. And it still exists, and it's still very valid. But ultimately, this is where you have a separate network organization where you submit tickets or you're bringing them to the table and they provision VLANs or PVLANs. You have a team that manages a separate SAN infrastructure, and that SAN infrastructure is something where you also maybe work through a service request mechanism, or you're exchanging emails or perhaps running a script, but it's not an integrated system in any means. All this stuff, and then of course you've got a series of compute, and that compute tends to be a lot of servers that you've tied together. Sometimes I call those pizza boxes, but you're stitching together a compute infrastructure, a network infrastructure, and a storage infrastructure to be able to provide kind of a virtualized fabric model. And there's a lot of drivers around this, but this basically is leveraging either fiber channel, which is what is described here, to get to that, or it's using some other form of block storage like iSCSI to be able to get back to your storage array. And networking runs on a whole separate infrastructure from this. And when we do this, a lot of organizations have done this because they've spent their organization may be structured this way. You have all these separate environments and you have separation of duties, and you need to keep those separation of duties. You may also have a lot of investments that currently exist. So you've got a SAN infrastructure you spent a lot of money on. That investment needs to be realized. Or you have a series of skill sets within the organization that need to be maintained. There's a lot of reasons why you would do this, but this is a model that works just as well as the others, and we're able to take advantage of all of this through a lot of interesting capabilities inside Hyper-V and System Center, and we've been able to do this for quite some time. Where the market's kind of shifting to is this converged architecture. This is high-density blade systems that we would pull together, and you're using a converged network architecture, or CNA, to be able to run all of your storage infrastructure, your storage traffic, and all of your networking traffic over a single pipe using QoS. So a lot of these technologies are things like fiber channel over Ethernet, and there's a lot of different names that OEMs will have for the types of storage interconnects that they have. But it's a reduction of complexity. It's a capital investment. These tend to be a little bit more expensive, but the idea is that you're able to reconfigure this whole hardware infrastructure based on your needs. And when you decide that that infrastructure no longer meets your needs and you need to be able to change that up, you get the flexibility inside the platform to make those changes. It also provides, a lot of these solutions that are out there provide a lot of integration. So you can automate a lot of the different capabilities that you would normally need to do through a ticketing system or through some type of informal exchange with your network team and your storage team. They're usually viewed as a single system that provides a single suite of capability. And that's one of the key differences between the non-converged pattern and the converged pattern. This is, again, a large capital expenditure we're starting to see, but this is where customers are driving a lot of their focus on these days versus the non-converged systems. This is where the investments are being made, and this is what some of those stellar solutions that you're seeing coming out of OEMs are addressing. The last pattern that's out there is software-defined infrastructure. This is a cost-driven model that uses a lot of in-box capabilities that the Windows Server Hyper-V and Windows Server in general provides to be able to take advantage of commodity hardware. This is a very popular design pattern within our service provider space, primarily because they're very cost conscious and are trying to focus this. They also have a lot of expertise in-house to be able to handle this. In fact, there's a really good presentation that you're not here watching, but Philip Moss is doing right now that talks about some of the software-defined storage and software-defined infrastructure models in action at his service provider. But ultimately, the idea is that we want to be able to leverage all of the capabilities that we provide in box to be able to replace some of those capabilities that you would see from Tier 1 solutions, such as SAN architectures. Through scale-out file servers and through storage spaces, we can provide a lot of the same capabilities using commodity JBODs. So we get basic deduplication. We get the ability to be able to segment spaces like you would segment LUNs, but you're doing it at a much reduced cost. Same thing with network virtualization. We use MVGRE, basically Hyper-V network virtualization, to be able to segment tenants in the same way and in a much higher scalability than we are able to do with traditional VLANs and PVLANs. So this is using some of those new innovations around software-defined networking and software-defined storage to arrive at that same model that we talked about before, which is that to be able to support 8,000 VMs. And we're using, instead of the others where they're using block storage, we're using file-based storage, SMB3 and SMB Direct over RDMA, to be able to provide high-speed access back to that storage. So each one of these 3 patterns really can be part of your fabric. And it's not something you have to jump in and make a choice all at once. You may start with a non-converged model because that is the model that you're used to today, but maybe you want to make some investments in a converged model. Maybe you want to take and make some investments in software-defined. We hear a lot of excitement around software-defined, but it's a change in processes, and it requires some analysis. And that's why we can support, obviously, and then why we also separate that fabric, because we can support more than one cluster. So fabric management infrastructure, again, is really focused on our system center space and Azure Pack. And it's important to understand the goal that we were trying to drive with this. So fabric management is about managing the fabric, one or more fabric clusters, and it uses a lot of components of System Center. But one of the key questions, and I just got it literally hours before I come in, is there's some components that are missing. You say System Center, but I was looking at the infrastructure PLA, and you don't have Configuration Manager. And yes, we don't have Configuration Manager in the PLA, and we do not have endpoint protection. What we're really focused on providing is, again, we're trying to look at those attributes that were listed in the cloud services reference model that we had. And so in CSFRM, management and support has certain capabilities, and so there's a lot of overlap between those capabilities. We also see that in Configuration Manager deployments, which can be targeted at servers, there's a need in the organization to be able to target other scenarios with that same infrastructure. So we pulled that off, and we really focused on a set of core components. So VMM, so Virtual Machine Manager, that's the heart and soul of our fabric management architecture. We need to be able to provide operations and visibility into the infrastructure through Operations Manager. Service Manager serves as our CMDB. Now, Service Manager can be used as a help desk system, but in this case, it really focuses as a collection point for us to be able to orchestrate different activities within the environment. And we need a CMDB to be able to capture a lot of moving parts and intelligence about the cloud system that we have. So we leverage Service Manager in that way. Orchestrator and SMA are our automation engines that we use to be able to stitch these things together. And we use Service Provider Foundation to be able to provide an API layer back to Azure Pack, our portal. So there's a lot of different components that we use to be able to satisfy those requirements in management and support. And so those are the components that we use. And while there's other areas and other capabilities we could add to this, this is where we kind of drew the line from a design perspective. We have other documentation that kind of couples along this. Much like our fabric, we have different management design patterns. Whereas our fabric was very much pivoted on storage, if you didn't notice the changes there and what ended up happening. Our pivot in here is Azure Pack and how Azure Pack is deployed. And we're really looking at a couple of different scale points. So this is a different model than what we've done on Fabric. Fabric is about hosting that. Management, there are different requirements based on whether you're an enterprise or if, whether you're trying to provide that to an internal organization, or if you need the scale points that some of our larger service providers need. So a couple things that you need to understand about System Center is there's different availability models, and this is for the entire PLA, and we've been thinking about how this works. So we have a host cluster, but inside that host cluster, we need to be able to virtualize these workloads and run them. So when we do that, we have a couple of components that are part of this that really focus on what we consider guest OS failover clustering. We need to be able to provide a SQL cluster, which I'm going to talk a little bit about here in a minute. And we also want to be able to, again, the heart and soul being VMM, we want to cluster that service so we can provide high availability and serviceability of that infrastructure. There are other components inside System Center that provide native application availability. Operations Manager being one, where you have a management server that has, either the agent is aware or there is a combined database that can be failed over. So Orchestrator is another. So we really look to leverage native application availability within those components where possible. Some components, primarily Azure Pack, are leveraging a load balancer to be able to provide availability of their components, and we use that model. And then last but not least is this idea, if the application or component either doesn't have availability or it's not easy to achieve, we've looked at using just the bare host itself. We look at some of those reporting capabilities that we would have, which are non-critical, right? If you have a report that's available, that tends to be ad hoc or you need it at certain points, but most organizations can live without a data warehouse for a few seconds while it fails over to the other node. So those are the types of things that we would be able to do to be able to provide that. So that's one of the key concepts that we have in our architecture guide. The other problem we have is that all the scalability of the different components are a little different. right? So how do you piece these together? How do you normalize that scalability? So inside, and by the way, all of these things are, I see people taking notes. A lot of this stuff is, all of this stuff is in the guides. So I'll give you a link of where you can pull this down. All this information will be in there. But ultimately what we had to do is we had to go ahead and normalize these because as you see, they have different scalability points, some of which exceed our service description and some of which need to be supplemented to be able to meet our service description. So what we did was we looked at all these components and went ahead and spanned them across to look at which ones we needed to scale out and which ones we needed to scale up. So there's a couple of choices when it comes to SQL Server. SQL Server, if Virtual Machine Manager was a heart and soul, definitely part of that beating heart is SQL Server, right? SQL Server is common to every component, and there's a different deployment model that's required for most of these components. So we tried to get into documenting these. And the first choice you're going to have is, do I deploy a SQL Server per component, or do I deploy a multi-instance failover cluster to be able to support that? Now, the problem with the first one, with a per component model, is that you have to provide availability of that database layer. So you begin to say, okay, one, for every component that we've listed so far, we need to have a SQL Server, and then based on that SQL Server, we'll go ahead and have to provide availability possibly with it, so we might need two. You suddenly instantly come up with what we consider to be SQL sprawl. It's not very manageable, it's not very serviceable, it tends to be a problem. It certainly works, but most organizations struggle with that. So we focused on, and we've had this for a while, a multi-instance failover cluster. So as you look at the models that we've put out, you may wonder why we went down this road. And the primary reason is we need to be able to scale. And that scalability is both scale up, but we also need to be able to scale out. If we see certain components that are getting hit very hard and they're starting to have different affect noisy neighbor problems with those other components from a database perspective, we need to be able to move that instance off to a cool node. Second is we want to be able to reduce that sprawl, and then we need to be able to do consolidation wherever possible. And not all instances can be consolidated. In fact, we've done as much as we can for this release, and we continue to do better, and my hat's off to the product team around this. Now, the other thing is availability models. A lot of different availability models exist within the platform. So SQL Server has always-on availability groups. People ask us all the time why we don't use that. We had a lot of talks with the product team as we were building this architecture. Failover clustering is what we use for on-site availability. It's the simplest model that we can provide to be able to allow for all of those instances that we need within System Center to coexist and to provide the failover mechanisms that we need with the reliability you need. We want to be able to use always-on availability groups for remote site failover, and we want to be able to use synchronous replication for that. So that's the two differences for this. There's a couple different best practices that we put inside the guidance that we have. So if you look at it, we provide a script to be able to slipstream your install so you can get the cumulative updates and you can get the service packs in. We provide all that stuff in our deployment guides, and we want to make sure that you understand all the permissions that are required as part of this. So all those things exist in the deployment guide as well. One of the things we did is we spent a lot of time trying to figure out how we could combine instances. You may see a lot of demo environments where they bundle all those things up, and they certainly operate at a demo level internally in the same instance. But when you start to run into scale issues, that's one of our pivot points. Is this a high, medium, or low workload? Is analysis services, which we tend to see when it runs some of those predictive reports that exist inside Virtual Machine Manager, can take up a lot of resources. So we need to be able to move that instance off, or at least place it to where it's not affecting other things. Some of these components work well together, and we can actually pull them together, and we've seen this kind of increase. The other problem you're going to run into is all of the different collation that's needed. And thankfully, over time, the product group has worked very hard in partnership with us, kind of identifying some of the issues, how to provide common collation across these. So we've removed that barrier largely, and then eventually what we hope to see is that all these can be combined in a single instance so that we can get away from this. But ultimately, the idea is that you need to be able to segment all of these different components in separate instances for various reasons. And what you end up with is this, after you do all this analysis, is what are all the different components that are needed, how many LUNs are required, what does that expected footprint, which components need to be located remotely, because there's some combinations or some settings that happen. So if you want to go ahead and set up Operations Manager integration with VMM, you need to be able to take the analysis services and reporting services and have that run locally on the reporting server of Operations Manager. All of that guidance is kind of wrapped up here so that we can give you both a logical diagram and a physical way to be able to implement this. How many people do a lot of work with AD or have done a lot of work with AD or managed that large Active Directory infrastructure? So every product that comes through the door, every solution that comes through the door always needs security, basically service accounts. There's a lot of security settings they need. Sometimes they need modifications to AD. Other times they need a series of groups created. And it always seems to be the same conversation. They come in and they say, we need some help. We don't really know what we need, but we think we've got a semblance of what we have to put in Active Directory. So System Center is a sticky solution that also requires Active Directory. And because of that, there's a whole series of accounts because you have a lot of different components. And these components have different needs. So we'll tell you in the Operations Manager instructions how many accounts we need and what those accounts will do. And if you go look in VMM, you'll see the same thing. And if you want to be able to stitch a couple things together, well, we need a service account for that or a run as account. And what we thought is, wouldn't it be nice if we could put this all in one place so you could take a table, send it over to your team, so when you sit down with the Active Directory team, they have something that they can quickly ingest. And we have clear reasons as to why we need those things. So what we did was we did that. And we want to make sure that as part of your any installation or deployment that you do this up front. That's probably one of your first steps is talking to your Active Directory team saying, we're going to need some things. Not a lot. But we definitely need to make sure you understand what changes we need to make to the directory and also just being clear about why you need those changes. We use a principle of least privilege. That's a big key that we do here. So you'll see a lot of accounts when I go to the next slide. But ultimately, it's because we provide a lot of segmentation between the different components. But we do, if you take a component-centric view, that's what you would end up with. And we try to reduce these as much as possible. And we provide a lot of details up front about what are all the different permissions that are needed because there's a lot of group nesting that happens. There's group nesting that happens on the servers. There's group nesting that happens on the different System Center component servers. There's group nesting that happens within Active Directory. And there's group nesting that needs to happen within SQL to assign all of those different permissions needed to be able to service this model. So we provide it in a very simplistic form. And now, you may look at this and say, boy, that looks like a lot of accounts. But for all the different components I've talked about and for all of the different pieces that it takes to build a private cloud, it's actually not much. And you'll find that a lot of this stuff, a lot of these accounts fall into this model of being able to do what we call CIs inside Service Manager. Again, trying to populate our CMDB with a lot of information. And I'm going to go through that in integration. But we leverage a lot of different credentials to be able to do this so that we can provide segmentation and provide that principle of least privilege. We also list all of the groups that are required, and we give really clear guidance on any other modifications that need to happen within Active Directory. And on the previous slide, I listed the basically distributed key management within VMM. That's the one container we need, and we need some very specific permissions on that. A very common mistake. There are some things that, depending on the configuration of your environment, that you may need to do. We cover all the different mechanisms so you can get those SPNs registered, you can get those service connection points registered properly and done right the first time. So that's a good question. The question is this so we can manage Fabric? And the answer is yes. So we can provide an integrated solution of System Center. So that's part of the challenge that we have is so that the System Center components can talk to one another. And when I get to the integration slide, I'll show a little bit of that. But they need to be able to communicate with one another so that they can go ahead and actually provide management of the Fabric itself. So so that's a good question. So you're asking about if you need to be able to manage a Fabric infrastructure that exists on an air-gapped network, or there's some kind of separation between them, maybe a firewall. So there's federated models in that sense, but you start to lose a little bit of fidelity of what you can do. To separate your Fabric management from Fabric in terms of the permission sets, like have them in separate Active Directory infrastructures. No, we wouldn't be leveraging that at all. We would use the same Active Directory instance for it as a primary mechanism to get this deployed. It certainly is supported. but it isn't our go-forward kind of first choice that we would do. And the architecture that we have assumes, and this is most of the deployments that we do with customers, assumes that we're deploying into a single Active Directory domain that customers have. The components certainly support that level of federation, but if you're looking to provide an integrated infrastructure, that would be our primary model. Now, there is models, and we have another architecture we do for service providers, which provides separation between tenants and their identities, and then the identity that's used for fabric management. But we still assume for fabric management and fabric, that Hyper-V cluster, because we have cluster name objects and we have all these accounts that are out there, that we use a single Active Directory for us for that. So VMM. VMM, a lot of questions we get is, why do we make that highly available? Why can't we just let the host cluster kind of take care of that? You know, the one that we use specifically for the management server, or what CPS calls the MSC, or the management service cluster. So we assume that we need that because it is, again, the heart and soul of our fabric, right? We need to be able to manage all of our fabric, and it's one of the two areas that I would say you need to ensure is available at all times, and you need to be able to service that independently of any other area. And we can't really see that going down if you have a series of consumers unless you have planned downtime. So we want to be able to deploy VMM in a fault-tolerant way, but that creates a little bit of a challenge for us because the VMM library cannot sit on the same cluster as the VMM server itself. So we need to put the VMM library also on a highly available model. So you can deploy it to one of those nodes, but then the VMM library itself isn't highly available. But we have a lot of clusters to choose from, and there's a lot of different ways. So we don't really recommend that you would deploy a separate file services cluster just to support the VMM library. That service can use the SQL Server cluster. It can also use the host cluster that the whole fabric management infrastructure sits upon. But ultimately, it does need to sit out there, and we don't really recommend that server sprawl to be able to support that. There's also a set of permissions that are needed when you do this against the library, when you build a highly available VMM service. So we kind of outline these really quick, and these are outlined in the document itself, but you need to make sure that the servers that are part of that VMM cluster, the clustered name object for that particular cluster, and the computer accounts are also added to that so that it can do refresh operations and other operations on the library itself. And that happens pretty frequently if you're familiar with VMM, so we want to make sure that those are in place. Windows Azure Pack is our primary pivot point. So now we kind of got some of that background down, looking at why we have different patterns within our fabric management architecture. It's primarily focused on Windows Azure Pack. So Windows Azure Pack, as you know, is our mechanism to provide an API layer that's common with our Azure service, but it also provides a kind of a friendly UI that is cloud consistent with what we do in Azure as well. And this is the two reasons why customers use this, right? So they can provide that common UI, or they want to be able to provide a common API to the services that are consuming it. So we have two different patterns, and the patterns have a couple of different key areas. First, we define what we consider to be a public set of services. So if you've deployed, how many people have deployed Azure Pack or have seen Azure Pack demos this week? So I'd encourage you to go to some of the sessions on this. There are a lot of roles. When you go and download the tools and you use WebPI and you install it, it will ask you about a whole series of roles, and I'll walk you through them here really quick. But what those roles end up doing is they have different needs, and they have different things that they support. So we have to go ahead and separate them based on what we consider to be a security boundary. So there are some services, APIs and portals, that we want to be public. There are others that we consider to be privileged, and we want them to be private. And if we were ever to put a firewall or air gap them in some way, we would do that in between those layers. We have two patterns. One is the minimal distributed deployment pattern, and one is the scaled distributed deployment pattern. Now, there's two other patterns that aren't listed here. If you went out to the documentation we worked with the product team on, there is the basic pattern, and there's also one that is called Express. Express is really what you would use to deploy an all-in-one solution for a demo, and we actually talk about that it's really lab environments and prototyping. The basic pattern really doesn't fit our needs because it doesn't provide that separation that we find that most customers want. Now, when we say minimal and scale, people think, we're a big company, I need scale. Right? we're talking about, between these, we're really talking about separating out different roles for the purposes of removal of roles in scale. Because sometimes we need to scale out different roles based on needs, and we have different scalability guidance that we give so that we can scale these things at a one-for-one with a particular role or pair them up. Minimal distributed really is a consolidator deployment, akin to what a lot of enterprises are looking to do. They're looking to get that capability, but both of these scale just out of the gate at hundreds of requests per second. And just keeping that in mind, it's hundreds of requests that we're able to do per second, which is something you would see a large service provider deal with, but not a lot of enterprises are dealing with that frequent of change. So minimal deployment works really well for a lot of our enterprise environments, even for some smaller service providers that we've seen. But ultimately, the idea is that we want to be able to separate by external tier-facing services, internal-facing tier services, and then supporting services. And identity and database are our primary two areas that we have. So we take roles such as tenant site and tenant public API, and we push those up into the external tier, because those are the services that are commonly used at an external layer. But we have APIs and authentication systems that need to exist internally, and for that purpose, we put those into a privileged service tier. Again, we don't recommend, out of the gate, we don't provide a lot of guidance on putting a firewall in between, but we know a lot of customers are doing that. So we needed to be able to provide a level of segmentation and protection that goes beyond some of those basic deployment patterns that we see online. The scale distributed deployment pattern is very similar. We still have our tiers, right? So we still separate public and we still separate privileged, but if you see, we take each one of those different roles that you have that can be co-deployed, and we separate them out. And we separate them out because there's a couple of key reasons. Service providers build a lot of their own portals. They build their own portal interface, and they're leveraging primarily leveraging our APIs to be able to extend their portal. They're using plug-in packages that they get with existing commercial portals. All those different services get pulled in and are represented differently. And so in those cases, they may not want the portal services that we provide. They don't want that user experience. They need to control it in different ways. They need to fulfill it. So they need to be able to either not scale those different components out, or they need to be able to remove them altogether. Because we certainly can operate in both those ways. But then these customers that are doing this type of stuff need to understand what are the critical components that they have. When they do scale out a particular area, such as tenant API, how does that, is there any other component that it's dependent upon? And if it is, do we need to scale that out at the same time? So we try to provide that guidance in the scale distributed deployment plan. Again, this creates a lot of systems, a lot of virtual machines, which requires a lot more management, but there's some payoffs available to this. So we try to go ahead and give you that guidance and make sure that you understand essentially how to scale this out if needed. We recommend primarily this for our service provider audience. That consolidated one is what we see for enterprises. So let's pull this all together. So now that we understand all the different components in System Center, we understand what areas that we have inside Azure Pack and how that gets put together. Well, how does that come together for fabric management design patterns? Well, we build two patterns for this as well. So we have what we call the cloud management infrastructure for enterprises, and we have scale-out cloud management infrastructure for service providers. Now, it could be that you're an enterprise of enterprises and you're managing a lot of different departments underneath your organization, and you need that scale that we talk about for scale-out management infrastructure. But the primary pivot with these is that you have a larger Azure Pack instance, and we expect a higher load, or we expect a lot more infrastructure tossed at it. So we leverage a 2-node fabric management cluster for the first one, which is our cloud management infrastructure. For that service provider model, we know that scale point needs to exist, and we need to be able to distribute the load on those. So we look at a 4-node management cluster, and we also need a 4-node SQL cluster paired with it. So the cloud management infrastructure model, and this is just kind of an eye chart, if you will, but we try to document all of the different needs that you have, all the way down to the storage per VM, the back-end storage you will need for the data warehouses, what we need from a placement perspective for all of the different servers. We also, as you notice, we have all the different availability models outlined. So we try to give you some very initial placement guidance that you would have, and all the cores that are needed, and all of the different VRAM, and all the things you would need to actually implement this infrastructure. Again, we separate this off of 2-node cluster on the fabric management side. When we scale out, we obviously, again, you saw that map of Azure Pack. We have a lot of roles, and those roles require VMs, and those VMs require different capacity. So we separate that out, and we give you a lot of placement guidance as to where we would expect that you would need to place these and how to go ahead and actually implement these roles are basically identified in our deployment guide that we have. So in short, a lot of this information is available in our 2 guides, but it gives you an idea of how we bring all these different components together to provide a fabric management architecture. So integration is a tricky point. Right? So this is a little bit of the challenge that we find, and we've kind of scattered these out here to kind of illustrate a little bit of this. So when you deploy the product, you're getting some very basic integration. If you follow some of the existing instructions that are out there, the models that we have really just provide some basic integration points between some of our components. But it really doesn't pull together all the pieces that you would need to be able to present this in a cloud or a private cloud fashion. So when you deploy some reporting, you get some reporting interfaces, but really what we focus on up front is how can we get the Hyper-V cluster under management? And how do we provide that VMMON integration so that we can do some of the rebalancing activities that need to happen within it? So we can do some of the power optimization and resource optimization that occurs. So there's some tricks to be able to get this to work properly, and we cover all of those things in our deployment guide. But ultimately, you need to understand that there's different integration points that are out there that need to be pulled together. Now, to be able to pull all this information in so you can begin to surface requests, what a lot of people want to do is IT process automation. So to be able to do this, you need to understand which hosts are the VMs residing on, how many VMs are deployed, what accounts are out there that can be used to surface these requests, who has authorization, which types of things do we want to happen automatically. So we use CIs, configuration items, and we have connectors within Service Manager to pull all this into a common CMDB. Again, you could turn this into a ticketing system and leverage Service Manager for that model, but we were really focused on leveraging it for a CMDB to surface orchestration. And we use integration packs to be able to do that within Orchestrator. And it has the ability to talk to all of these different components and do certain actions in a simplistic way. So ultimately, what we're trying to enable with the PLA is this ecosystem. And hopefully this has kind of helped illustrate a little bit of what we were trying to do inside the product line architecture. So first off, we want to be able to give you the ability to purchase by SKU against our OEMs. We want you to be able to pull this content and be able to purchase with some level of kind of confidence that you're going to be successful. And we want you to be able to order hardware in days versus weeks. We want to make it very simple for that. We ultimately, if you're a service provider or an enterprise or a little bit of both, we want to make it very simple for you to deploy. And we need you to deploy in weeks, not months. Right? We think this can be done. We've done a lot of work with customers that we think it can be done in somewhere between 5 to 8 weeks, depending on level of understanding within the organization. In some cases, people have been able to deploy this in a matter of a week and even days using some of the automation that we've provided externally. And really what the business is interested in is the business is interested in a lot of these scenarios, these capabilities that they're trying to drive within the organization. And they have a series of workloads that they're looking to be able to deploy. And we want you to be able to focus on that. Because all of this stuff over here, from an IT perspective, us as IT pros trying to build cloud architectures, this is very interesting to us. But to the business, they're very much focused on workloads, and they're very focused on these scenarios. They want to light up hybrid cloud. They want to support IT process automation. They want to enable dev test. There's a lot of different things that your organization or the organizations you support may need. I'm sure you hear this from the business all the time. And we really want you to focus on those complex scenarios versus focusing on all of the bits and parts it takes to get there. We need to be able to move very fast into that model, get over that fatigue. So all these materials are available. And a lot of people say, where do I get them? Well, we have all the materials are wrapped up on this short URL. So you can go to IaaS entire set, so AKMS/IaaS entire set. You can download all of our materials. You can get all the information that we have. And we keep these up to date as we make changes to the platform, as we release new versions. We make sure that this is accessible to you. All right, with that, I guess I can answer a couple questions. I'm sorry, go ahead. Oh, yeah, absolutely. I'll leave this up for you. Yeah. Yep, it will be available. So the question is, will the presentation be available to download? Yes, it'll be available out on Yammer. It should be posted here shortly. So that's a good question. So there's a couple of ways that we can do that. We support direct integration with App Controller. It's another component that we document, so you can have kind of that bifurcated deployment. So let me actually restate the question for those that are listening. So the integration with the cloud, how can we integrate things within Azure? So migration can happen in a number of different ways. We have a lot of tools, and there's some realities to how you would move things between cloud architectures, right? We have different PowerShell commandlets that we can use to be able to migrate that. We can leverage automation that we support here. We also have direct kind of portal integration with App Controller, which is a component that I didn't show up here, but it is one that provides kind of access to VMM clouds and to your Azure subscription. So that's all documented inside the PLA. So that's a good point. So monitoring as well, absolutely. So there are management packs within Operations Manager, and the same fabric that we have that we use to be able to monitor the fabric can be used to be able to plug in those management packs to provide management and monitoring of workloads that exist in the cloud, including your Azure subscription. So best practices of management of the fabric versus management of the tenant itself. So that's a good point. So we have a document that we have that's on our partner network that we use that talks about kind of that exact point. So essentially what it boils down to is who manages those workloads, right, and where those workloads are joined. So if you think about if you're doing tenant-based workloads, if you're providing the management infrastructure, if you are the face of management within your organization, ultimately the identity and control needs to live within your organization because they're never touching that. They're never touching Active Directory. They're never touching any of the workloads itself. They're consuming something from those workloads. If they're actually deploying workloads that are integrated with the Active Directory, so Exchange is a very good example, you would need to create a tenant identity infrastructure. And we have some models that we have out externally that talk about that. But essentially, the primary reason is if you are providing a service to customers and you have an SLA for those services, you don't want them to be able to disrupt those. The only people that should be able to disrupt that is you, right, as the provider. You know, so kind of protect your interests. Otherwise, you need to create an infrastructure that they manage fully. So for those scenarios where you have, like, say, an Exchange organization that's deployed on top of this that's managed by the tenant, we would create a tenant-specific Active Directory instance that's managed by you to be able to provide that service, and then you would use federation back to their identity infrastructure to be able to provide access to that.
Yeah, I think that's why I was surprised when you said
Oh, I see the point. Yeah, so it just depends. It's mostly the management point of view. If you are providing a service, you would want to have a separate Active Directory infrastructure to manage specifically your fabric and fabric management. Mm-hmm.
I have a single business, but yet I want to use the shared components to manage fabric and manage tenant side of the business because I know if any of those components get compromised, someone can compromise the fabric.
Correct, but your fabric, you should be managing your fabric under that same instance. I think the separation would probably be who has the ability to, where is that line in the sand? So your question is where do you
For best practices, like let's say I have a patching infrastructure,
Mm-hmm.
the patch for tenant, and the same is used as patch for fabric. It doesn't make any sense.
So that from that perspective, you're right. You want to provide probably some workload separation. So there's the layer of your workload itself. So the workloads that you have, you may want to have a separate infrastructure managing them. So the tenants that are consuming those services, you can have that level of separation. But your fabric, the Hyper-V cluster that's connected and that's providing fabric services to that overall cloud, I think your fabric management and your fabric need to exist in the same Active Directory infrastructure for those models. It's because your users, your tenants are not managing the fabric, they're consuming that fabric. But to your point, For some of the management servers, we see separate operations manager infrastructures out there. We see sometimes separate service manager infrastructures to be able to support help desk ticketing. And we also see different services that are out there for patch management that happens. But for the overall clusters, the Hyper-V cluster, providing fabric, basically patching of your fabric, keeping the cloud operations going, those infrastructures live within basically the PLA that I described here, the PLA architecture. I can show you. Maybe we can come up after this. I'll walk you through a quick model. I'll bring up a document that'll kind of show a little bit of what we're talking about there. But your fabric, it's all about where the line is between basically who your consumers are and who the provider is. And if you're the provider, you want to have direct control over a series of things. Absolutely. Yep, absolutely.
If someone shuts down your fabric, whatever thousand VMs you're running there is down.
I don't think you want separate infrastructures for each one of your fabrics, though. I think that's part of the. I'm sorry.
What do you mean by each one?
Well, so each Hyper-V cluster that you would have is part of that, or each fabric cluster that you would have.
What about data centers? What about regions?
For different data centers in different regions, you can certainly have that, but we would kind of expect that they would be in the same forest. That's going to provide you the highest degree of compatibility.
Yeah, but so you have some availability zones sharing the same Active Directory. That Active Directory goes down, both of your availability is not going down.
No, Active Directory can span regions, right? You can.
It spans, but if someone compromises Active Directory, most of your regions will go down.
Well, I guess I think you could go down that road of a lot of the different compatibility layers. We should probably take this offline and talk about it up here, but you're going to run into a level of separation, right? That you can create so much redundancy and so many levels of separation that you create a complex environment. It's very hard to manage.
So let me ask you, in Microsoft, in Azure, you have availability zones, right? Or regions.
We have regions.
So the fabric management is done by.
It's a different model. We have Windows Fabric. We're using different tools and capabilities inside Azure to manage our data centers. So we have a Fabric Controller, and the Fabric Controller provides a lot of the capabilities that you have here. But it's a different model and a different set of tools.
The orchestration of those availability zones, right, is capable to reach out to another availability zone to make changes there, or it's only isolated.
Within Azure, we have the ability. That's all managed by the Fabric Controller infrastructure. So that's a different model. We're using a different identity structure. It's probably not fair to make comparisons between the two. But I'll walk you through what we do. We've got a service provider architecture that we can walk through, and I can show you a little bit of what we're doing there. Are there any other questions? Yes, the new announcements that have been made this week. Yeah, well, so our primary pivot for the PLA is product release. So we will focus on, and we do this every time a new version of the product is released. We work very tightly with the product team. It's positioned as a partnership that we do. So the PLA would be updated to include all those new capabilities when they're released. You'll probably see pre-release versions happen, and we've done that in the past. But we will provide kind of guidance as to where that would go, and we'll have a final architecture as those products reach a little bit more maturity in the dev cycle.
Does the stack replace the pack, or is it in addition to the
I think, well, a lot of that stuff is being announced by the product team a little bit, but there's, I think you would be safe to say that the Azure Stack is what they described earlier this week is going to be a bit of a replacement for what Azure Pack provides or an extension of that. Yep.
Probably just rename the 15 development stack.
That's it.
Probably just to rename the 15 development stack. Development stack, Azure stack.
I can't comment on any of those things. I don't work for the product team. They could kind of tell you a little bit. Well, anyway, thank you very much, and I could go ahead and catch up with you offline. Thank you for coming.